Okay. Very good afternoon, all. We'll wait for 5 more minutes to join other, and then we'll start. All of you. The screen is visible. All of you. Is the screen is visible? All of you. Okay, now let us start. So till now we have completed the fourth unit, and today we are going to discuss about the fifth unit, and that is what we call the central processing unit. Can anyone define what you mean by the CPU? We have the central processing unit. What the CPU stands for? Yes, anyone? What the CPU stands for? What all the CPU stands for?
Central processing unit.
Now, for what we use that CPU?
For
For our
processing and
processing
executing
and
instructions.
For processing. What kind of the processing we use that?
computational process and
Kind of an
other
arithmetic, logical operations, or handling the task, we use the CPU. The CPU in general we call as a simple, a small microprocessor. Okay? Okay. Fine. Starting with today in this chapter, we are going to discuss about the introductions, what are the general purpose organizations we have, stack organizations, instruction format, addressing modes, data transfer manipulation, program control, and the reduce instruction set computer. So to start with the component of the CPU. What does the component of the CPU consist of? The part of a computer that performs a bulk of data processing operation is called as a central processing unit. Do some process on any data we call as the CPU. Okay. Let's suppose consider here this register set, that is a general purpose register, and the arithmetical logical unit will be controlled over here. Okay, and the whole, that is what we call a central processing unit. Okay, I have a bunch of data that should be processed in ALU, and that's why we call it a central processing unit, and also it's controlled that which data need to be added, which data we do the AND operation or operation, any kind of the operations. So arithmetical logical unit perform the arithmetic and the logical operation of the data, and the control unit generate a signal to transfer the information between the register. Okay, and the register state are always be used to store the data for a temporary. Now, when you compare the two structure, or when you compare a like a computer structure, you always compare the structure in terms of instruction format. That suppose the one computer is of 16-bit, another computer is of 32-bit. So obviously the 32-bit have a more number of instructions to be executed because the number of opcode has been increased. So you can compare in that way. Either you can able to compare in terms of addressing modes also. I suppose the 16-bit have only 3 addressing modes, whereas in the 32-bit we have 5 addressing modes. So you can compare your computer system with the comparison of the addressing mode also. The instruction set, obviously, as I told you, if you have a 16-bit instruction format, you have the less number of instructions, and if you have a 32-bit format, you always have a more number of instructions over there. And the last, the general organization of the CPU register. So how you manage the registers, because in the 16-bit it decides that how much of temporary registers you can able to use, and the 32-bit tells that okay, compared to the 16-bit you have over here the more flexibility to be used instead of 6 register as 8 also. Okay, so these are nothing but a different computer structures or architectures to be compared. Starting with the two types of architectures we have. One architecture we call as a von Neumann architecture, and other architecture we call as a Howard architecture. Can anyone say what is the difference between these two structures? All of you? What do you mean by the von Neumann architecture, and what do you mean by the Howard architecture?
the hardware architecture. There is a CPU is connected through the data and program memory, and
Wherever in the von Neumann, we have one common
one
memory.
human they are separate. Yes.
Okay, they have a one common memory but separate memory. In a one memory, it's a 1 by 2. Okay, so anyone can say that which will be the faster. Like if I have a two different memory And for what we require the two different memory? Can anyone? The regular student? Yes, anyone from the computer student? Which will give the faster execution of a speed if I have the two separate memory or if I have one single memory. The separate memory. Jaishankar, but which we have a separate memory? There are the two things I require in memory to be stored. One is a program and one is a data. So my whole memory should be divided into a two types. One is the program memory and one is the data memory. I am telling that in the one Newman architecture, I have one common memory, whereas in a Howard architecture, we have two separate memory, the program and the memory, program and the data memory. If you are telling that, okay, fine, I understand that what the Jaishankar said, the answer, if you have a separate memory, it will give the faster execution. Can you give me the reason, Jaishankar, why? Why the separate memory give the faster execution? Yes, anyone? Jaishankar said is a separate memory gives a faster execution. Why? What is the reason? Every instructions will be independent and get the faster access. Okay, it works on a specific property. Okay, many answers. Okay, one will run instruction and second will display and store instruction. Let's suppose consider it's like a one Newman architecture is like a consider there is a one building and there are multiple flats are there. And in Howard architecture it's like the separate flats are there. Okay, the separate flats are there. So here, once the person is standing over here, I'll ask him to go to the first floor and find out how many members are there in that flat. So he'll go to the one flat and he'll find it out and he'll give me the answer. Again, I'll ask this first person to go to the fifth floor. Again, he'll go here and he'll give me the data. So the jumping of one location to another location is very difficult if we have one single memory. Let's suppose it's same like the program memory, same like this one memory have one memory which is divided in two parts, program memory and the data memory. So when the program is executing, if I need to read the data, I need to go to the data memory. Again, I need to read the data and again I need to come back. Okay, so the jumping from one location to another location in the one memory, that consumes more time. But here, let's suppose I have the different houses or different flats, and if I'll ask that, okay, read the data from here. So directly it'll go here and it'll read the data and directly it'll give it to me. Okay, so the Howard architecture works like this. They have the different program memory, they have the separate data memory also. Is it clear, all of you? Is it clear, all of you?
Yes, sir.
Okay, now let us understand by the technical terms how it will be. So this is what we have. So I have the memory and the code, that is the program memory and the data memory. Code means program, data means the data itself. So the two memories together, program and the data memory. So I must require a data bus and address bus separately, one bus to read or write the data and the addresses, and it is given to the CPU and it is connected to the input and output port. So this is the architecture of an one Newman architecture. Here, if you look at the Howard architecture, what I have? The ALU access to the control unit with the two different memory. One is the instruction memory and one is the data memory. Again, this one is the data bus and this one is an address bus. Okay, is it clear, all of you? Understand the two different architecture, all of you, except Jay, Harsh, and Yash. What about the rest of the students? There are 70 students out there. Okay, good. Just a minute. Okay, very good. Now, here, if I'll try to differentiate these two things in terms of flexibility, speed, and example, let us talk about first flexibility, which will give you much more flexible, which will give the more flexibility.
Harvard architecture.
Flexibility in terms of what I'm asking? Listen, one more thing. Let's suppose if I need to increase my program memory, I have the less data. So in that perspective, you tell me the answer, okay? In terms of program and data memory, you tell the answer. Okay, the path you say is a Harvard. Okay. Anyone else telling that okay, one mnemon is more flexible compared to the hardware? And can anyone give the reason behind that? Okay. Avinash said, what do you mean by that? More flexible F means what? Avinash? Here the flexibility in sense, let's suppose consider. I had used this much of memory for a program and this much of memory for a data. But after that, I realized that, okay, I have more program length and the less data. So what I can do, I can modify it to the, okay, I can access this, some of the data memory to the program memory, and I can able to increase this thing. This is a program and this is the data memory. So this is a more flexibility we are getting in the one Newman architecture. But here what we have, it is already like program memories and data memories are always be fixed. We cannot able to assign some of the program memories to the data memory. Are you getting or not? The thing is clear, all of you? If you want a more program memory, you can use a more the what do you call, instead of 64 KB, you can use the more because the size of the memory. But what happens over there? The wastage will be more because you know it always comes the memory in terms of 2 raised to n variable, the numbers. Okay, the wastage of memory will be more. Let's suppose I need in just a very small program, and I must require the large data memory. So you can adjust according to that. Okay, the more space. Are you getting or not? So which will be flexible? The one Newman architecture that will be flexible over here. Okay, the Howard architecture is the limited flexible. Is it clear? Why? The reason? All of you? Is it clear? All of you?
Yes, sir.
Okay. What about the speed? Which will be the more speed? Which will be the more speed? One Newman or the Howard architecture?
I think one human, sir.
Okay. Okay. What about the rest of the students? Yes, Weibo, Sayas, Silpi, Anjana. What do you think? Which will be the faster? The one Newman or the Howard architecture?
So maybe Howard.
Maybe Howard.
I mean, I'm not 100% sure. Like,
Okay. How you said is the Howard architecture? Correct. What you said.
oh, sir, because it's having more that data buses and so than one human.
Data bus and address bus are same only. One data bus, one address bus.
Then
The
send my
two
answer
sets
is
of
correct, but
memory.
logically wrong.
As I told you that once, if you consider an example of the building, what I said, according to the building, what you say that which is the faster? The Harvard is the faster because we have the two separate memory. So reading the data from one memory, the program counter don't have to jump to the data memory and then again go to the program memory. No, that much of time can be saved over there. Okay, so it always be a faster whenever you use the two set of memory. The bus means the data can be handled more quickly, which will be result in decreasing the execution time. And the speed is limited when compared to the Harvard due to the only one memory locations and the setup of bus. Clear all of you? Which are the examples? If I talk about the simple examples, there is a computer is an example of a one Newman architecture. The small system, okay, like a washing machine, alarm, automatic chocolate vending machine, the traffic light, everything are made up of an Howard architecture where the data are different. So these are the nothing but the total three difference we have the flexible. There are more differences are there, but here these are the three difference from where we can able to understand the things. What I want to say here, this is a general purpose register R1, R2, R3, R4, R5, 6, one decoder, three multiplexer, two multiplexer, and one ALU. Now, Look at the diagram and try to understand the operation. Okay, and tell me the reason that why two multiplexer and one decoder I had used over here. Okay, look at the diagram, all of you. Why the multiplexer and the decoder has been used in the design?
Which instruction or data to be taken for to the ALU will be decided through MUX.
Okay, then why the decoder?
Decoder is for
Let us give the example. Let us I had given you the example. Think in that perspective.
first it will select content of R2 and through decoder it will select the register which data to be taken through to the MUX. It will send both data to first and second MUX and the result will be stored in the R1.
Okay. Till what is the job or what is the decoder? Put it over here in a diagram. I didn't get the answer. Yes, anyone? The regular students, the computer. Okay. Decode the register instruction. Hmm. Look at the diagram. Just understand why the multiplexer and one decoder has been used. Okay, R1 that is interrupted through decoder. Good, yes. Good, yes. Only yes. Sanjay wrote the answer and Parth wrote the answer. Parth will discuss the answer. What about the rest of the students? Register selection. Very good. That is what the direct answer is, I know. Yes, Archit. Okay, let us discuss this thing now. Consider the R1 and R2 and R3 needed to be added. So here, look at this. The answer what I will get from an accumulator that will be written inside the R1, R2, R3, R4, R5, R6 and R7. Total 7 registers are there. Okay, now 3:8 decoder we have. That means if I select 0, 0, 0, that means the answer what I got it from accumulator that will be written in R0 somewhere. Okay, if I'll write 0, 0, 1, that means this data will be written in the R1. If I write 0, 1, 0, the data will be written into a R2. And 0, 1, 1, if you write, the data will be written in R3. Okay, so this is how we can able to write the data of answer, and that is why the decoder has been put it over here. Now consider the mux. Out of this 7 register, I need only R2 and R3. That means I must require 2 multiplexers. So here this multiplexer will tell the selection of A. If I'll put the selection of a 3-bit, I need R2. So 0, 1, 0. So R2 will be selected here, and it will the A bus R2 will be available. If the selection line is B is a 0, 1, 1, that means R3 will be available over here, and the B bus will be loaded with R3. Clear this all? Understand?
Yes, sir.
Okay. Now for this, what is this? Why is OPR is there? That is of 5-bit. Why? What is the reason?
Which operation to be performed
Which
in ALU?
operation? Because correct part. Here the ALU is nothing but an arithmetic and the logical unit. It can able to perform arithmetic operation. It can able to perform logical operation also. So what kind of operations can you have to be used, or which kind of operation to be performed on this R2 and R3, that will be decided by the operation OPR. All of you clear about this? Yes or no? So what do you think that how many opcodes are possible? How many opcode are possible? How many opcodes was possible? 3 only, Arshit. How it will be 3? How many opcodes or how many instructions are possible? 8? No. 6? No.
2⁵.
2⁵. How many bits here? Total 5 bits are there. So how many possibilities of instruction is 2⁵? Is it clear, all of you? Is it clear
Yes.
why the 2⁵?
Yes, sir. Yes. Clear.
Okay. Now let us come to the first. What happens? It will select a multiplexer. That means R2 will be loaded into bus A. Selection B, R3 will be loaded in a bus B. Then A will do the operation, depends upon the operation bits. And the decoder will select the destination register, select D. Okay, and that the data will be written into one of the registers. Okay, the out bus will be written into R1. So this is a step we have. Now let's suppose consider, if you want to find a control word size, control word means last time we had seen the definition of a control word is nothing but a group of a bits we call as a control word. Now here I have the selection A, selection B, selection D and operation to be performed. Let's suppose consider 3 bits must required, here also 3 bits, here also 3 bits and here the 5 bits. Why? What is the reason? Anyone can tell me the reason why 3 and 5? Why the 3 and 5?
So 3 is for the register selection.
3 is for register selection.
5
Okay.
is for operation, opcode.
Okay.
in the ALU.
Okay. Good then. Okay. Like 3-bit for selection to multiplexer. Selection D is for decoder, and the operation is of 5-bit. Total this many bits are required. Let's suppose consider this is what the binary codes R1, 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 R2, R3, R4, and R6 and R7. And this is an operation. This many bits. There are the possibility of a 2 raised to 5, but I had used this many bits only for doing the operations. Okay. Take the screenshot of this slide, total slide. Take a screenshot of this slide. Okay. Now, tell me for this, the number of bits. First example, R2 minus R3, then the data should be there in R1. Write down the answer in terms of bits. The number of registers are 8, so the selection line will be 3. That is okay. Answer for this. Let's suppose perform R2 minus R3. I need answer. Write down the answer in terms of selection A, selection B, selection D, and operation. The bits. For first example, I am doing like this. R2 register, so 0, 1, 0, R3, selection D, the answer is in 1. Which operation? 0, 1, 0, 1. Same way, now do it for this shift left R4. What you will write? Shift left R4. Total Harshit, how many bits we have? 3 plus 3 plus 3, that is 9, 10, 11, 12, 13, and 14 bits have. Write down the 14 bit at a time, Jaishankar and Harshit both. Do you understand the reason behind the register not used for R0 in this? Do you understand why we don't use the register R0 directly? We started from R1 because some instruction might be possible that increment R1 you don't require another register, and that's why it has been empty over there. Okay, second one, selection A. Do we require selection A? Yes, we require.
Yes, sir.
That is a
Yes.
4. I don't want this R000, and that's why none of the register will be selected. Okay, so R4 Then write it the answer in R4 again. Do the operation shift. What about R1 direct R7? What should be the answer for that? Okay, very good. First register, answer will be stored in R7 and 000. What about last one? Okay, Jasinka. R2 and directly sent to the output. So none of the registers have been selected. So both are 000. Clear this thing? Okay.
Yes, sir.
Now the next questions is always be like they're asking it. What do you mean by the register stack? Explain the push and pop micro operation. Or they might be asking like explain the register stack and memory stack with neat sketches. Explain the push and pop operation on a stack, and what is the register stack? Explain with example. So here understanding the register stack is important. Okay, so in the register stack, how the stack operations will be performed. See, again I am telling stack memory are always be used to store the data temporarily. Okay, that means you can able to use that kind of a memory to store the data like kind of a return address. Return address are always be stored for a temporarily. Okay, then again the program counter will go to the subroutines, it will read the data of the return address and then it will come to the main program. So that is what we call stack location. Now how the stack memory are looks like? It's like in the book what we had used. What kind of book while you just explain the stack operation using this figure, it's very easy to understand. So when you start putting the books on another, and if I'll ask you, take one book at a time, okay, and the stack of a book should not be fallen down. So what you do? You're not able to start taking the book from last, correct? So always take the data, or you always take the book which is already been put it on the first, means last what you have put, that you will take at the first, correct? And that is what we call stack memory. That means how you are filling the data in a stack memory, but you can able to access the data what you had filled at last only. Okay, that is what we call stack memory. So here it's same as a game like small students used to play this thing, the rings. Okay, so this first item will be received first, and then the second, third, fourth, and then we come to that last. Okay, if you want to fill your stack location, you can go on increasing, and if you want to empty your stack memory, you can take the data one by one out. Okay, it's kind of a LIFO. What do you mean by LIFO? The last in, first out. Okay, which you have put the last, you can take the first out. Okay, so when you are inserting, putting the books one on another, we call as insertion, and when you are taking the data, we call as a deletion. That means you are deleting. That means you are deleting the data. Okay, in the stack memory. So when you are putting one book on another, we call as a push operation, and when you are taking the data, that is nothing but we call a pop operation. Okay, so it requires some time to understand the things. So I'm not explaining the rest of the things. We will discuss from here in the next class. Okay, because it's a this the push and pop to be understood very nicely, and within I think don't think the 10 minutes I can explain you that thing. Okay, till that I had just opened the assignments what I told you. Those students have not uploaded, please upload it. And till that, for the EC students, I am making one new canvas module for the path and all. So we'll use to upload directly on that only. Okay, so we do not have the mixed things kind of. Okay, till that, all the other students go to the assignment one and experiment also. That is not possible. Mahesh Nayak, in the stack memory, you cannot able to do like that. Okay, you are not able to. That is happens in a primary memory, like a program memory, but you cannot able to do in a stack memory. Clear? Yes, the EC students, check your mail. Might be you got a request to attend the DCO subject.
For Canvas, sir,
Yes, of the canvas.
we already enrolled them in that.
That is the combination. Like it's computer students, I don't want because both of them have a different teaching scheme. Better we
Okay.
make a different canvas for you all,
Right,
and
sir.
there we'll upload the things. Okay.
No, sir, there's no mail.
સર મેલમાં તો નથી એવું પણ ડેશબોર્ડમાં દેખાડે છે ઈસી ડિજિટલ કમ્પ્યુટર ઓર્ગેનાઇઝેશન
Yes, yes, correct. Accept that.
મેલમાં નથી ડેશબોર્ડમાં કેનવાસમાં છે.
Okay.
Sir, I would join later because I do not have the laptop now.
Will be fine. Okay, that will be fine.
સર એક્સેપ્ટેડ.
In that, there are the two assignments are there, 1 and 2. Okay, and the two experiments are there, 2 and 3. Just upload that things. If you had uploaded in that also, just upload the same copy here also. Okay.
Excuse me, sir.
Yes, Nandini.
Sir, I'm going 5 minutes earlier because my phone battery is almost dying.
No, just write down the attendance. I'm taking the attendance only. Easy students, write down the attendance.
Thank you, sir.
Mahesh, I think is remaining. Mahesh. Okay. Fine. The regular students, the computer students. In a sequence, write it down attendance, and those who wrote, they can leave. Upload the experiment. After that, the no date will be exchanged. Computer students, again, I'm telling.
Sir,
Yes, Sanjana,
due to network issue, I was not able to write my enrollment number.
tell me.
014.
Okay, I wrote it down.
Sir,
Yes,
sir, even I'm not able to write my attendance.
tell me, Milani.
023.
Okay,
Sir, done?
I wrote it down in the chat box. Okay, then you can leave then. Thank you. Yes, Manish Kumar, Nishita, any problem? Any question? Yes, Manish Kumar, Nishita, any problem?